Alright, first question, we've got a box that starts with some initial speed and it slides from one platform to the other side that's higher, assuming that friction and air resistance are negligible for the system consisting of the mass in the earth. What happens to the total mechanical energy? Well, first, friction and air resistance are negligible, meaning that work is not being done, so energy is conserved, so the total should remain constant. What if friction was not negligible? Then your total mechanical energy would be decreasing the whole time because you'd have work being done. Friction work only is like losing energy. Alright, a ball is dropped from the top of the cliff. Assume no air resistance or friction, so energy is conserved. The potential energy, so think about, if I drop something from the top of a cliff, I start with some potential energy for sure. I know that it's decreasing. This is potential energy versus time. Your potential energy is not changing at a constant rate because your height is not changing at a constant rate. It's getting faster and faster, so it would look something like this. Now your kinetic energy, as it falls down, your kinetic energy is obviously increasing. It says that it's dropped, which means initial velocity is 0. So then as it goes up, it should be increasing. This is 1/2 mv squared, so it's not just a straight line because the velocity is increasing at a constant rate, right? It's increasing by 10 meters per second each second, but it's getting squared, so it would look something like this because the two of them must add up to the total energy, and the total energy must be a flat line, constant. So this one plus this one adds to constant. Now 3, same idea, but now I've given it an initial velocity. So as it falls down, it's also moving sideways. Your potential graph has not changed, right? It's still going from this height down to the ground. It's still accelerating at the same rate. But my kinetic has changed because now I have kinetic at the beginning. So I have not from rest, but I have some kinetic energy and it's increasing. So the same as before, it's just shifted up because I start with some kinetic, which means my total energy is the same before I just start with a greater amount of energy. That's it. So again, these are the same, it's just kinetic is greater, therefore total must be greater. Right, number 4, we've got a horizontal force F. It's used to pull a 5 kilogram block and has a constant speed of 3. The frictional force between them is 10. So friction force is 10. It says the object moves 5 meters. How much does the kinetic energy, how much kinetic energy does the block gain? That's supposed to be how much kinetic energy does the block gain. So think about it. You can think about it as 1/2 mv squared, right? How much is this 1/2 mv squared changing? Well, it says the constant speed of 3 meters per second. If I were to plug in 1/2 mass of 5, 3 squared, you get 22.5. Now that doesn't give me the kinetic energy gain, that gives me the kinetic energy that it had. And if it's staying at a constant speed, then you are not gaining kinetic energy. So your answer is 0, right? You're not gaining because it's at a constant speed. If you got 22.5, yes, that is kinetic energy. That's not what I asked for. I asked for how much the kinetic energy gains. So that's not helpful, right? It doesn't matter what it is. If it's staying the same, it's not gaining. The other way to think about this is in terms of work done, because some of you might have said, well, the change in energy is just work, which is force times distance. This is not the only force, right? If it's going at a constant speed, that means they have balanced forces. So that means I also have an applied force of 10, which means my net force is 0, so then work is Fd. I would use my net force, which is 0 times 10, which is again 0. So then the change in energy must be 0. Now, if that horizontal force were increased to 15 newtons, right? If I have an applied force of 15, but I still have the same friction, right? Because I didn't say friction was increased. How much kinetic energy would it gain now over 5 meters? So now I have a net force of 15, or of 5, not 15. So my net work would be force times distance, which is 5 times 5, which is 25. So that is the work done. Work is also the change in energy. So how much energy did I just gain? I just gained 25 joules. Car is traveling on a level road, flat road. Level means flat. With a mass of m and an initial velocity of v naught. There's a coefficient of friction. What is the shortest distance they can travel when they lock the brakes? So they stop, right? Lock the brakes until it stops. Here, energy is not conserved because you're talking about friction. It said you're on a level road and you're moving and then you stop, right? It's not like this went into potential because it didn't say anything about going up. In fact, it said level road and there's no spring to absorb it. So work is being done, so I'm going to use work. Work is equal to change in energy, which is also equal to FD. In this case, my change in energy, the type of energy I have here is kinetic, 1/2 mv squared. Here I have 0. So my change